Hello, this is Santosh Shinde, IT Department, VPKB IT Baramati. We are talking about cloud security, and we had already seen in part 1 the encryption and hashing mechanisms used for cloud security. Now here in this video we will be talking about two important concepts under cloud security. One is digital signature and another one is public key infrastructure, or that is abbreviated as PKI. So first is digital signatures. The digital signature mechanism is a means of providing data authenticity and integrity through authentication and non-repudiation. So you basically wanted to provide data authenticity, and for that we use digital signatures as well as data integrity. A message is assigned a digital signature prior to transmission, which is then rendered invalid if the message experiences any subsequent unauthorized modifications. So there are any tempering of the message or any modifications of the message in between the source and the destination, then the message is rendered invalid and it is rejected. A digital signature provides evidence that the message received is the same as the one created by its rightful sender. So the destination will come to know, or the ultimate recipient will come to know, that the message received is as it is without any alteration as it was sent by its rightful sender. Both hashing and asymmetrical encryption are involved in the creation of a digital signature. So it's kind of a mixture of hashing as well as asymmetrical encryption. Asymmetrical encryption we had seen where we had public key and a private key combination is used, and in symmetrical encryption we had seen that the same key is used for encryption and decryption. So in asymmetrical encryption, which is also called as public key cryptography, if you use private key for encryption, then we use public key for decryption and vice versa. So asymmetrical encryption and hashing mechanism that we had seen, both are involved basically in the creation of digital signature. So we had seen asymmetrical encryption and hashing in part 1 of this video. Now in part 2 we are focusing, as I said, with digital signature and PKIs. So hashing and asymmetrical encryption are combined here, which essentially exists as a message digest that was encrypted by a private key and appended to the original message. So we are creating a message digest in the form of a digital signature, and we append that to the original message as if it has been signed by someone. So it's a digital signature. The recipient verifies that signature validity and uses the corresponding public key to decrypt the digital signature, which produces the same message digest. So here is the mechanism used for digital signature. This is cloud service consumer A, which is going to act as an attacker. This notation is used for showing an attacker, and this is a genuine cloud service consumer B. So he is sending a message. Along with that, a digital signature is also been appended with the original message, and that message goes to the cloud through this firewall. Now this message along with its digital signature has been received, but before it reaches to the virtual server B, what had happened is the cloud service consumer A, which is an attacker, it has somehow attacked on this particular message, and the altered message is now with the harmful data which has to be rejected. So here you can see that the message is being rejected. So cloud service consumer B basically sending a message that was digitally signed but was altered by a trusted attacker. Since this is also a cloud consumer, A is also a cloud consumer, it is a trusted attacker. Virtual server B is configured to verify digital signatures before processing incoming messages. Even if they are within its trust boundary, it has to verify the digital signatures. The message is revealed as illegitimate due to its invalid digital signature, and therefore the message is being discarded. So this is how the mechanism works. So to summarize, a message is assigned a digital signature prior to transmission. We are assigning it a digital signature, which is then rendered invalid if the message experiences any subsequent unauthorized modifications to it. A digital signature provides evidence that the message received is the same as one created by its rightful sender. And again, I repeat that it is making combination of hashing and asymmetric encryption mechanisms. So this is all about digital signatures. So here there is one more. Whenever a cloud consumer performs a management action that is related to IT resources provisioned by DTGOV, the cloud service consumer program must include a digital signature in the message request to prove the legitimacy of its users. This is something as an extension to the topic, that whenever a cloud consumer performs a management action that is related to IT resources provisioned by DTGOV, then it has to have a digital signature. So here is a cloud resource administrator. Here you can see management message plus a digital signature is yours, and usage and administration portal is there, which verifies the digital signature. Here we have resource management system, SLA management system, and billing management system of the cloud. So it has to have a digital signature. That's all. Next is public key infrastructure, PKIs. PKIs basically rely on the use of digital certificates, which are digitally signed data structures that bind public keys to certificate owner identities as well as to related information such as validity periods. Digital certificates are usually digitally signed by a third party certificate authority. So PKI, a common approach for managing the issuance of asymmetric keys, is based on public key infrastructure mechanism, which exists as a system of protocols, data formats, rules, and practices that enable large-scale systems to securely use public key cryptography. This system is used to associate public keys with their corresponding key owners, known as public key identification, while enabling the verification of key validity. PKIs rely on the use of digital certificates, which are digitally signed data structures that bind public keys to certificate owner identities as well as to related information such as validity periods. Digital certificates are usually digitally signed by a third party certificate authority, CA, as I said, as illustrated in figure 10.7 in this figure. The common steps involved during the generation of certificate by a certification authority. So here are the steps. First is here the cloud consumer's private key and the cloud consumer's public key, both are used here, and it goes to cloud consumer's public key. This is cloud consumer's data. So basically a cloud consumer sends a certificate request to the cloud consumer data, where it gets the cloud consumer's public key and the cloud consumer's private key. Both are shown here. Cloud consumer's public key is taken here in order to generate the certificate. Now here it goes to the certification authority, CA, and what it uses is cloud consumer's public key and cloud consumer's data is there. Hashing mechanism is used here. So a hash tag is generated with the CA's key is also used here, and a CA digital signature is generated, that is then forwarded to CA digital signature. Here it is attested by the certification authority. So here certificate properties and cloud consumer data is again used, and cloud consumer's public key is formed. So this way the PKI mechanism works. These are the overall steps. Public key infrastructure, PKI, larger organizations such as Microsoft can act as their own certification authority and issue certificates to their clients and the public, since even individual users can generate certificates as long as they have the appropriate software tools. PKI is a dependable method for implementing asymmetric encryption, managing cloud consumer and cloud provider identity information, and helping to defend against the malicious intermediary and insufficient authorization threats. The PKI mechanism is primarily used to counter the insufficient authorization threat. So here is one more example. An external cloud resource administrator, here is that external cloud service administrator, uses a digital certificate to access the web-based management environment. DTGOV's digital certificate is used in the HTTPS connection and then signed by a trusted certification authority. So that is demonstrated even while dealing with digital signatures also. We have seen this particular issue, but now here the DTGO is digital certificate is used in the HTTPS connection, and then it is signed by a trusted certification authority as such. Thank you.